All right, so we are going to be starting our first set of notes for this unit and our first video notes on Coulomb's law. So this should be on page 1 of your packet. Make sure that you follow along on your page as we go through this. You will be responsible for getting this stamped in class today, so make sure that you get it all finished. So for the first part here, we've got some different charges that we're going to look at, and you should have learned this in 8th grade already, so we're going to go pretty quick through it. When we have the same charge, so the pluses are positives, so here we've got two positives right next to each other. Since they're the same, they are going to push away from each other. So we can just draw the arrow showing that these are going to be pushed away. We call that repulsion. Okay, because they are repelling each other. So we call that process repulsion. Okay. A big mistake I see people make is negative charges you put drawing together, but in this case they are still the same charge. Even though they're not positive, they're both a negative, which means these are also going to be pushed away from each other. The only time that we get them pulling together is when they are opposites. So when one of them is a positive and one of them is a negative. This is the only scenario where we get arrows where they pull together. And we call that process attraction. So we're just going to write a quick rule for these charges. So you've probably heard this before, but the same charge, they're both the same, they repel. And then the very popular saying, opposites attract. And that's where it comes from. Opposite charges are going to attract each other. Throughout this unit, we are going to be doing some math problems, which means we need to know the units that we use to measure these charges. In this case, we use a Coulomb, similar to the name at the top of the page. So we use a Coulomb, but of course we don't write out the full word. We use the symbol just C for Coulomb. All right, so we do need to know an equation to be able to solve problems for this. This is going to be very similar to other equations that we've done in this class. So here we're going to be doing an equation for force, and we know that the symbol for that is F. F for force, and then I'm going to do a little subscript C because this is the force of the charges. So FC for the charges equals. Now this might look a little bit weird at first. We'll talk through each step though. We've got a fraction. So you can draw that bar for a fraction. And then we've got K, Q1, Q2 on top. So K times Q1 times Q2 divided by D squared. Okay. So let's talk about what each of these symbols mean. We already talked about, we know that FC, that's just referring to the force. So that one is what we're calculating, is the force. Some of these symbols we haven't seen before. We haven't seen K or Q before. K is an easy one because it's a constant. So you're going to use the same number for K in every single problem, which makes them nice and easy for us. K is equal to 9 times 10 to the power of 9. Okay, this is going to be our main number that we use for this unit. This is called Coulomb's constant. So we've got 9 times 10 to the 9. Always, that's what we plug in for K. Next, we've got the symbol Q. We've got two of them. That's because whenever we do one of these problems, we have two different charges. So one of them is going to be Q1, the other one's going to be Q2. So both of those, Q1 and Q2, those are the charges. And D is something that we've seen before. So d squared. D stands for distance in this class. So this is going to be the distance between the charges squared. And if this equation seems kind of intimidating right now, we're going to do an example down below where I break it down step by step, and you can get a chance to do some practice after that. So let's take a look at this example. What I like to do is underline the numbers that it gives me so that it's a little bit easier for me to see what's going on. So we've got a +3 charge and a +2 charge, and they are separated by a distance of 2 meters. Now we need to figure out if they are attracting or repelling, and then what is the electrical force between them. The first question is super easy for us. We want to know if they're attracting or repelling. If we look at the signs, we've got a positive and a positive. If we look back at the top of the page, we know that when we have two positives, they are going to repel. So I'm just going to circle on my page here. They are repelling. Okay. The second question we have to use our new equation for. I'm going to write out what I know. So right off the bat, we know that K is always 9 times 10 to the 9. So I recommend that you just start out by writing that down so that you remind yourself K is 9 times 10 to the 9. Q1, that's going to be our first charge, is +3. Q2 is our second charge. We've got a +2. And then d squared, our distance, was 2 meters. So our distance is 2. We'll square it later when we plug it into the equation. And that's all the numbers that it gave us. So now what we need to do is plug those numbers into our equation. We've got FC equals 9 times 10 to the power of 9. I replaced the K with a parentheses. So every number that I plug into the equation, I'm using parentheses for. So Q1 was a +3. So I'm going to put that in parentheses. Q2 was a +2. Put that in parentheses. And then our distance is 2 to the power of 2. Now the reason that I put all of our numbers in parentheses like this is so that it's easy to plug into our calculator. So if you notice, all of these parentheses correspond with the letters up here. So we've used our equation properly. Now all we've got to do is plug in the numbers. So in the calculator, we're just going to plug it in exactly how we wrote it out. So in parentheses, 9 times 10. And if you've never done an exponent before in a calculator, it's this little caret button right here. So I want to the power of 9, so I'm going to do caret 9. So that's 9 times 10 to the power of 9. Then next to that we had a +3, a +2, and then that 2 squared is on the denominator, so we just need to do divided by 2, and then the squared button is right beneath that little caret, so we get that squared. Now we can press equals, and you'll notice that the calculator spits out something a little bit different than what you might have seen before. So we get this decimal 1.35, and then right next to it is this tiny little times 10 to the power of 10. We need to include that when writing down our answer. So this problem, when we write it out, is going to give us 1.35 times 10 to the power of 10 newtons. And I'm going to box that up because that is our final answer. And notice I added newtons as our units because this is a force. So remember, whenever we calculate force, our units are newtons. So on the back of this page is going to be a couple of examples that I want you guys to try on your own. So if you go to page 2, this is what it should look like. So go ahead and take a second to try this one on your own. If you're getting kind of stuck on this, maybe call me over and this would be a good time for me to help you during class. If not, we'll check our answers in class in just a little bit. So take a second, try this problem. If you finish before we get to it in class, then you can move on to the next section of these notes.